event, a build-a-thon event coming up. Yeah, starting next week. It goes for like weeks 3, 4, 5, 6, 7. This is an optional thing. It's nothing to do with this course. You don't get marks for this course. It's just I'm advertising it for the society in case any of you are interested. It might be fun. It might be a good learning experience. There's information. There's an info pack. I'll post all this stuff on the forum in case anyone's interested in joining. But like, it's nothing to do with this course. You don't have to do it to get marks. I'm just letting you know. Because actually, I do get emails sometimes from students saying, what else can I get involved in, you know, to help me build things or for fun, whatever. So that's one thing, and I'll put it on the announcements in case anyone's interested. The other thing is, has anyone already done this quilt survey? Okay, so I think you all got an email with this survey, right? So I don't mean fill it out right now, but if you've got time later, fill it in. It's really beneficial. It allows you to give feedback about UNSW, and it's run by the government. It's anonymous. That's just another thing I wanted to show you. And that's also up on the forum. Yep.
Is it compulsory to answer?
It's not compulsory to answer this survey. Yep. So these two things I've just said aren't compulsory for this course. Just letting you know about them and encouraging you to do this one.
So it's just for feedback?
It's for feedback about the university to the government, yeah, right. I believe, yeah. So, all right. Another announcement. This is relevant to this particular course. There are help sessions starting. So they will be starting next week. We'll have a schedule very soon on Sunday. So on Sunday, we'll announce it on the forum, right? Yeah? Yes. We'll announce the schedule. But these will be sessions that some will be in person, some will be online. You can walk into those sessions and get one-on-one help with a tutor. And we've got them, we'll have a schedule for the rest of the term out there. But I will say, during these earlier weeks, they're a lot quieter. So if you go, it's easier to get seen earlier. If you go the actual day an assignment's due, there'll be so many students there. So get in early and start getting help now when it's not as busy. That's my advice. So keep your, and I know, I know some people enrolled into the course late or didn't get into Sydney on time and might be a little bit behind. So these would be a great chance for you to get some help catching up if you need it, okay? So these are optional classes. They're for you to get help if you need it. Make use of them. All right. So Monday's lecture, we covered, does anyone without reading this remember what we covered? We did if statements, basically, and we learnt about conditions and different kinds of operators to create those conditions. There was a couple of things in the slide I didn't get up to. One of them was a nested if example, which I'll show you today because that'll be good revision of if statements. And while loops. I didn't know that we'd get up to them, so I put them in case. We're going to do those today, all right? Then we're going to do more while loops, nested while loops, and talk about some custom data types, hopefully. As always, our live code is up on the course website. So the week 2 code is up there already. I'll also be modifying it during this lecture. But before I do that, I just want to, we didn't do a Kahoot last time. I just want to do a Kahoot now. It's a bit longer, but it's really going to go through all the basics that we've learnt before we go and do harder stuff, just to recap it in your brain. So let's jump straight into a Kahoot. Wake you up, get your brain going. Also, we've got chocolates as prizes. If the admin team wins, we'll take the person who comes fourth to get prizes as well. So the first 3 get 3 chocolates, 4th and 5th can get 2 chocolates. we promote people from 4th if an admin team wins. Okay, let's start. Okay, cool. Yeah.
I don't know how else to do this. Let's just do it quick. So video ninja. Boop. And then
Oh, was I supposed to do
video?
that?
No, that's okay. I don't think I've told you how to do this before. Cool. Okay, great. And then back. Thank you.
Thanks. All right, I'll wait another minute or so for people to join. Actually, just while we're waiting for more people to join, I had a few questions about auto testing for labs. So you're allowed to run auto test as many times as you like. That doesn't matter, that's not going to affect your mark. If the first time you ran it, you failed all the tests, that's fine. What we mark is what you submit and your most recent submission. So the last submission you submit is the one that we run auto tests. So we might have a few different auto tests than the ones you've run, but that's what we run them on. Does that clear up your questions? Okay, cool. All right. I think we could start. Is anyone not joined that wanted to join? Okay, it's stuck around us. Oh. Should I start? Yeah, let's start. I don't know how to get the sound on for the... Are you missing the beautiful music of Kahoot? Okay. So lots of people got the right answer. Anyone that put int mark, the red one, that's right, but that declares the variable. Initializing it is giving it a value, but that's still like legitimate C, so that's good. All right. Okay, Rapid Hawk. Wherever you are, well done. Okay, again, most people got this right. If you got the red one, a few people got the red one, you've just forgotten this ampersand that we need. We need this thing here when we do our scanf that we don't need with printf, right? That ampersand character. next. Okay. Now we start straining your brains. Okay, so we've got lots of people trying to do normal maths here, saying half of 500 is 250. So if this was a maths class, that would 100% be the right answer. But remember, in computing, well, in C, we've got 1 divided by 2. 1 and 2 are ints, right? Sorry. 1 and 2 are ints. Sorry, I'm shouting too much because I can't hear myself. When I divide 1 and 2, what do I get? Yeah, we've got integer divided by integer. We don't get any fractional component, so we get 0. Is everyone happy? Okay. All right, keep going. Okay, so well done. A lot of people have the right answer here. So can anyone explain why is it 250 this time? Yeah, at least one of them's a double. So I've got 1, which by default is an int, divided by 2.0, that's a double. It does the whole division as a double. We get 0.5. And then we do normal kinds of math stuff, right? Okay. Excellent. Most people got the right answer. Now, if you got 3, perhaps you were dividing. So remember, that percentage sign means mod, which is the remainder. So if you divide 17 by 5, you get 3, remainder 2. Okay. And this is one to make you cry. Not really. Oh, too easy. Too easy. With the 20-second thing ticking, I thought it would be harder than that. All right. Again, we're trying to hurt your brain now. So a lot of people got that. That's great. So that's just, we did this in the last lecture. So if you're thinking, I've never seen this before, we did do it. This is how you can convert between uppercase and lowercase. And I kind of explained it in more detail. You can do it the other way around to convert from lower to upper. And that's something you're going to see again in tutorials and going to do in labs. All right. We've still got a few more now. Ah. Okay. First of all, does anyone recognize this picture? That was one of the class's flowers from the tutorial. All right. Okay, when we do hash define, and this is just a minor syntax kind of thing, we don't put that semicolon there, and we don't put the equals there. And we don't use include. So that's just a syntax thing you're going to remember with time. Oh. If there's a semicolon, it could cause the code not to compile. Because if where it's putting that, you wouldn't be able to put a semicolon, it might mess things up. Excellent. And only 2 people wrote to make our lives more difficult? Okay. Okay, winged deer, wherever you are going well? We're getting into some logic now. Okay. Why is this true? Yeah, so there are 4 penguins. Well, there were in the photo. There are 4 penguins. They're not the same height, but we've got an or. So as long as one of these parts of the condition is true, the whole thing's true. So that's why we get true. Awesome. And they both have to be true, and they're not. Okay. Couple more to go. The pictures don't help. They're for my benefit, my entertainment. Okay, so yeah, we can compare characters. So A comes before Z in the alphabet, and it's handy that the ASCII table is laid out. So all of the lowercase letters are in order. All of the uppercase letters are in order. So we can check if A is less than Z, and we know that it is, hopefully, yep. It's not some kind of clue. Okay, you're doing well with these. So, yeah, 7 is less than 15. Gosh, I had to think for a second. That's a bit of a worry. 8 is not greater than or equal to 15, though. So they're both not true, so the whole expression's false. Great, you're all doing well with this. Only one of them had to be true because it's an or. Very good. Okay, wonder owl. Last question. Ooh. So, why is it false? So, we just did this inside expression, right? So 5 is less than 10. Shh, shh, shh. So that's true. Oh, I'm writing in white. I'm wondering why I can't see anything. So that's true. 6 isn't greater than 13. That's false. If I've got true or false, I get true, right? With or, we only need one of them. So this whole expression in the middle is true. Gosh. If I put a not in front of true, what does it become? False. So that not turns a true to false or turns a false to true. It kind of reverses the logic. Okay. So let's see who our winners are today. Stella Kitten. Oh, awesome. We've got some chocolates to give out. Yep. Okay, Stella Kitten, keep your hand up. We've got Winged Deer. There's Stella Kitten, Winged Deer, and we've got Wonder Owl. Is Wonder Owl here? Ah, okay, cool. All right. There's one over here. If Winged Deer is here somewhere, come up in the break or something. If you're at home, I don't know. We can work something out later. All right. Thanks everyone for playing. We're going to get back into the lecture slides now. All right. So this is a nested if statement here. So that just means we've got if statements inside if statements. This is not really a new concept. The same logic as if statements, but now it's just trickier because we've got if statements inside if statements. And we can have if statements inside if statements inside if statements inside if statements kind of thing. But at some point, if you've got like 100 nested if statements, it's probably not a good idea. In this course, we're limiting it to 5. And there's a better way to do what you're doing. However, we don't know how to do everything yet. So at the moment, we might have a bit more nesting than you might have when you know more different ways to code. But yeah, having some nesting is normal and fine. Just notice with this indentation, the way we space the code, we've got this open bracket and this open bracket. So all of this stuff aligns one indentation level. Within these if statements, I've got an open bracket here, close bracket here, and that's indented another level. This is indented another level. This is outside these ones, it's back in, right? So it really shows you what's contained inside what if statement. Yep? Oh, I think that there's this and this. And then there's this one with this one. And then there's this one with this one. So this is the outer if, yeah. Does that make sense? Yep.
Within the nested if statements, can we define like things in like is it better to do it outside the if statements or can we define new things within the
Okay, so this was a question. Can we define things inside our if statement? So you're saying, can we say int y equals 5 or something?
So like
Yeah.
on a certain condition, if it's met, then it does something where
Yeah, you can define variables inside there. That's correct. But you won't be able to use them outside of that contained open and closed bracket. So if I put, I don't know, int y equals 7 in here, I won't be able to use that y like down here or down here. Yeah.
would you have to or so you wouldn't be able to actually pull that value outside of here?
It only exists within these open and closed brackets.
And there's no way to pull it out?
Well, you could just declare it up here if you wanted to use it everywhere.
Okay, so if we declared it like up there
And then down, yeah.
it meets all like the at least like calculations within the
So you could declare it up here and then say y equals 7 in there. Yep, that's correct. I'm just going to actually go through this code and run it. I'm disconnected from Tiger VNC. Ah, okay. Oops. Yeah, did you have a question while I'm...
Yes. Can I pick a variable that's made in the if statement to compute something outside of the if statement?
Yeah.
Oh,
I mean, depending on the exact thing you're doing, yeah, all right. That was, the question was just, can I compute things inside the if statement for variables that were declared?
Oh, no.
Oh.
Reverse. Variables that are declared in the if statement is used for another calculation outside of the if statement.
Oh, if you declared it in the if statement, you can't use it outside of it. Yeah. Okay, so let us, I can't do two things at once quite clearly. All right. Wrong folder. Okay. So if we'd just written this code ourselves, what would we want to test? What would you think? I want to test this input to see if it works. What are some inputs that we do? Let me compile this. What should I type in? 101. Who said that? Yeah, that's a really good one. Why? Because we've got this 100 here. We want to know 101 would be like a boundary case. What do we think it's going to do if we type in 101? So, yeah, we read in 101. So is 101 bigger than 0? Yeah, that means we go inside the if statement, which means we're never going to go inside this part here. we either do this if or the else that's attached to it. If it's 101, we're doing the if. Is 101, and then we just keep going. The next line here is 101 bigger than 100? Yeah. So we know that we're going to go in here, and that means we're never going to do this else part here. Does everyone agree? So it's going to print out big. That's the first thing it prints out. It's finished this if part, so it skips past the else part. What's the next thing it's going? What is the next thing it's going to print? Yeah, positive. It's now done this sort of outer if statement. We know it's not going to do the else. It skips past here. What's it going to do now? Yeah, print number. So you apply the same logic that you would with if statements. Just gets a bit trickier for our brains once there's lots of them nested, you know. But let's just check it though. Big positive number. Okay, what else might we want to check? I might want to check, yeah, negative number. So -1, what do you think that's going to print? Yeah, it's going to fail this condition and go into the else and print out not a positive. But this is not inside an if statement. So this is going to be printed at the end every single time. Okay, yeah, a question? If we put 0, it's going to print, yeah, not a positive number. Now, again, people in maths might disagree with what we talk about 0, but I don't think 0 necessarily is a positive number in maths. I don't think it's positive or negative. But sometimes in computing, we might lump it in with positive sometimes. It depends on what we're actually trying to achieve. Yep. But yeah, that's 0's a tricky one. All right. The other case that we haven't tested, like there's a path through this nested if statement that we haven't tested yet. Yeah. So that would be, like, what about 100? Yeah, small positive number. Yep, so anything but like from 1 to 100, we're going to get small positive numbers. All right, and typically we would make sure we tested maybe 100, 101, we did that, 99, 0, 1, -1, you know. Is everyone happy with the nested loop part though? The nested if statement part. Okay. All right. Now, if I change my keyword if to a while, I actually get a loop. A loop is something that gets repeated again and again and again. Now, with an if statement, if the condition is true, it'll execute it once or not at all. With a while statement, it'll check that condition. If it's true, it'll execute it. It'll check the condition again. If it's still true, it'll execute it. It'll check that condition again, etc. And while loops are really important and powerful, because this is the stuff that allows us to do lots of things quickly that would be tedious for humans. All right. What do you think this code's going to do? Other than send a very positive message, you know. So what does 1 mean if I've got a condition 1? True. So if this was an if statement, it would execute, I love my COMP1511 lectures, it would execute that once. Because this is a while loop, it'll check, is 1 true? Yes. It prints it out, it goes back to the top. That's why we call it a loop. It checks, is 1 true? Yes. It prints it out, goes back to the top. Now, this is an example of what we call an infinite loop. Because if I compile this and run it, this would just go forever, okay? Often when we do an infinite loop, often when you will do infinite loops, we do them by accident. So often we accidentally make them infinite loops because we've forgotten to do something that's going to help it stop. But in this case, I did it on purpose. Now, when you do it, whether you do it on purpose or by accident, you don't have to shut down all of VLab and start it again or anything like that. Just press Control-C. It's in the notes, and I think it'll tell you in the labs. DCC is printing out errors, like stuff to help us. We don't care because we did it on purpose. All right. So that's a loop. Now, we've got to take more care when we do our proper loops where we want to do something that does something, important. Now, here's another one, and this is kind of more like the ones you might accidentally do, right? So I've got a variable called push-ups, and I've set it to 0. I'm then comparing push-ups to 100. So I'm asking, is push-ups less than 100? Now, right now it's 0. It's going to print out you have done 0 push-ups. Now, this is going to be an infinite loop, right? Because we never change the value of push-ups. Push-ups is always 0. It just keeps printing out that we've done 0 push-ups. Let's try it. You've done 0 push-ups. And I'll be honest, I have done 0 push-ups. But imagine this was a push-up counter and you were doing push-ups, yeah. How would we make it actually say you've done 0 push-ups, you've done 1 push-ups, you've done 2 push-ups? Yeah. So this is what we sometimes forget to do in our code. We sometimes forget to do something to update it, like just because we forget. We know in our head that we meant to and we just forget. So we can do something like push-ups equals push-ups plus 1. And now, every time it checks, push-up will have a different value. And eventually, push-up will have the value 100, and it won't actually go through that loop. The loop will stop, right? It'll say, is 100 less than 100? No. It'll jump down to here, outside the while loop, and it'll keep executing whatever code is there. So then it should say, congratulations, you did 100 push-ups. Okay. Okay, rather than going forever. Is everyone sort of happy with that? Okay. All right. And we could have it the other way around as well. We could start it at 100 and say, you've got 100 more push-ups to do, right? And then every time you did one, you could subtract 1. You've got 99 more push-ups, 98 more push-ups, like a countdown. We could do it like that too. Let's just try it. I'm starting at 100. Okay. And I'm saying push-ups equals push-ups minus 1 each time. What's going to be the problem with this? Should we try and run it? Yeah, it's going to be another, let's just run it. Yeah, well, so it doesn't really do anything because our condition's already false before we start. Okay, so what should our condition be in this case? When do we want to stop? So if it's greater than 0, let's try that. Actually, let's not be so hard on ourselves. Let's do 10 push-ups because that will fit in the screen better. We can see it better. Okay, we've got 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Congratulations, you have 0 left. So, you know, we call these kinds of loops where we've got a counter counting loops. And these are really common where we're going up by 1, going down by 1. We just have to make sure we remember to modify our variable so we eventually make sure the condition is not true. We could even cheat and try and do 2 push-ups at the same time. We won't do that now. Any questions about these loops? We're going to do more on loops, but these are the basics. Would you like me to go through it in more depth? Yeah, I'll do that with another example. Yep.
This is not in regards to loops, but I wonder, it gets more interesting, I think, if we start understanding how to get inputs from other machines. I wonder whether we'll be covering that by any chance.
We're not getting, in this course, inputs from other machines. Just people, like just, yeah. Yeah, we've got a question. Yep. Oh, okay. So, we'll have a break in a minute. Just give me 3 more minutes. Okay, so these are my examples of while loops in real life. So while the bowl of chips is not empty, eat chip. That's a while loop I do. While in lecture stay awake, that's a while loop I hope you're doing. Yep.
So if I want to have an if statement inside the while loop, and then I want to end it later, what's the code for that?
Oh, we've got some advanced questions already. Can we have if statements inside while loops? Yes, you can. And then how do you set it up? It's going to depend. We'll see some examples in a minute when we do some more while loops though. Okay, so just one word of warning. People might be tempted to just copy and paste. Like I could have, if you need to do something 5 times or 10 times, you might be tempted to just copy and paste the same code 5 times or 10 times, right? Especially if you're a beginner. That's not going to be feasible for things where you're doing it 1,000 times. Or even that situation before, oh no, we could have just copied and pasted it 100 times, right? But we don't want to do that in this course. Okay, we've done that. So let's have a quick break and we're going to come back and look at a few different types of loops. Then we're going to look at nested loops. So let's have a break until, 5 past. 5 past. The break's over. Shush, everyone. Shh. Okay. All right, we're going to do more loops. So we're going to show you, I guess, 3 different styles of loops. The terminology for these things isn't the most important thing. It's more that we're just showing you a few different types of things you might do with loops. So the first one is similar to what we just did, right? This is called a counting loop. We've got a counter. We're starting it at 0, which is a typical thing to do, and we're going up to some limit. So this is going to print out, here we go, loop-de-loop. How many times? How many times is the loop going to go through, do you think? Yeah. So this is where we can get into confusing situations in computing with these off by 1 errors. Is it going to print it 10 times or 9 times? Especially when we start counting at 0 a lot of times in computing, and then we've got less than, or is it less than or greater than, that might make a difference. So let's go check it out. Now, instead of doing it with 10, I'm going to change it to 3, okay? And I'm also going to print out the value of the counter each time. So we can actually see. And I might even print out the counter at the end. So are we thinking it's going to print it out 3 times, 2 times? Oops. Okay, so everybody, yeah, it printed it out 3 times. So the counter starts at 0, and 0, let's just step through it. 0 is actually less than 3. We print it out. And now we increment the counter to 1. 1 is less than 3. We print it out. We increment the counter to 2. 2 is less than 3. We print it out. We increment the counter, and our counter now ends up with 3 in it. 3 is not less than 3. So the loop ends, and we print out this last thing. So when it's 0, it went through the loop. When it was 1, it went through the loop. When it was 2, it went through the loop. Okay, so starting counting at 0, which we often do, can throw you off a little bit. And you'll often be out by 1. Luckily, you can run it and test it and then realize. Okay, so that's a counting loop. Now, sometimes we don't have a situation like this where it's obvious that we're just going to go through and keep adding 1 and go up to some limit. And basically, all loops have conditions in them, but we call these more general loops. We just call these more generally conditional loops. Now, this one is a lot more complicated. So let's have a look. What's happening here? I've got a kombucha limit of 2,000 mils, 2 litres. Now, whether this is in for a whole day, a week, a morning, I'm not going to say. While the total mils of kombucha is less than or equal to the maximum, and we've got to work out, is this the best way we could do this program? Anyway, it's going to tell us how much we've drunk so far. So at the beginning, my total is 0, right? But then it tells me to enter the amount of kombucha. So if I drank this, or if I was about to drink this, I'd type in 330 mils. Whereas if I was drinking a can, maybe I'd type in 250 mils, or a bigger bottle, 750 mils, or whatever. Doesn't matter if these mils are correct. for this particular thing. So depending on how the size of the kombuchas and the amount of mils I type in, I might loop through this loop, 10 times, twice. We don't know until the user's entered the data. It's not always going to execute X number of times. But each time I just update my total kombucha with whatever I've just typed in. So let's try it. I'm trying to work out where I should run it because, there's not enough room on the screen. So, what am I doing? Oops. So, oh, now we can't see it properly. I might bring it up to here. I've drunk no mils so far out of my 300, out of my 2,000. But now I'm, getting, it's a 330 ml bottle. So now it's telling me how much I've drunk. I can just keep saying, okay, now I've drunk a 750 ml bottle. Now a 330 bottle, and it keeps adding up this total. Eventually, it says, actually, if you drank that 750 mils, that would take you over the limit. Stop. Okay, stupid program, but this is just sort of a more general loop where now next time I could say, okay, I'm drinking a 1.5 litre bottle right now. And now it's going to stop after 2 iterations through the loop. Okay, but again, really, we do just have a condition. We've got some kinds of variables that are eventually going to reach it. Is there any way I could type in stuff that would make this just keep going? Like, let's think of how we could break this. Yeah. I could just cheat and say, okay, but now I've had negative 1,500, and all right. So technically, yeah, maybe we wouldn't reach the end if I was doing tricks like that. Let me just get out of that. The other thing is, what if I just enter 2,000 at once? What's it going to do? Is that going to... It's going to say, yeah, this is what it's doing. It's letting me go through the loop. And it's going, yeah, okay, have 2,000. But then the next time through the loop, even if I asked for 1 mil, it's going to say no. So I don't know, it raises my hopes that I can have more, and then it just cuts me off, I guess. So, maybe we'd want to change the behavior of this. But look, it depends what you're trying to do. We could make it less than. If we made it less than, then it says stop, as though I wasn't even allowed to drink it. So, in these situations, we might have an if statement at the end. Say if my total kombucha was exactly equal to the max, oops, something like that. So if we ended up right on target, we get a great but no more. If it would end up being over target, we say stop now kind of thing. But these are just the fine tunings. Whereas if I type in 5,000, hopefully it will say, please just stop now. So this is just a more general kind of loop. Does anyone have any questions? It is a bit messier and complicated compared to the counting one we saw. Yep.
After the second comment, why did you break the printf statement of kombucha so far?
Ah, now this is a good question. So if I had it like this, what's the problem with this in terms of style? Yeah, it's going to be more than 80 characters, and this line is telling me that. So if you go to the style guide, it actually shows you ideas how to lay your code out in these situations. And that was one way you could do it. Another way sometimes can be, if you've got lots of variables that are making it wide, to lay them out like this. So I can't remember who asked that, but yes, yeah, that was you. That was a good question. So yeah, again, when you're doing an assignment or something, if you end up with a really long, wide piece of code, go and check out ideas on the style guide to see how you might want to space it out. But these are a couple of ways. All right, this last type of loop is called a Sentinel loop. So sometimes the condition that the loop ends is something that the user types in, like a specific piece of data. So it might say, please enter integers, and to end, type a negative number. And our while loop is going to keep reading in positive numbers, and if we get a -1, it'll stop the loop. So we call this a Sentinel value. It's a value in the data that means we no longer have any more valid data, please stop. Another thing might be, please enter integers and press, I don't know, any other character that's not an integer to stop. Kind of thing like that. And this is a common thing that we get users to do. Type in data, have a special non-data thing that they enter that means stop. That's what the Sentinel means. Now, in this implementation, there's a few ways you can do these loops, but we've got a variable here. This is the number that the user is entering. So we've got a variable for that. And we've got this variable here called end loop. And we're kind of using this as a flag. We sometimes call it a flag. So we set it to 0. And while it's 0, we keep going through the loop. Now, in this particular example, if somebody enters a negative number, oh, thank you. If somebody enters a negative number, we're setting end loop to be 1. And this is like waving a flag saying, please stop the loop, please stop the loop. We're setting that variable to be 1. So next time around the loop, the condition will fail and we stop. Okay. Sophia's running around trying to close all the doors. I don't know if wind's blowing them all open. There's workmen out there. All right. So we've got this flag variable. It's just a variable. We've set it to 0 to indicate end loop false, no. We read in numbers. If one of our numbers is less than 0, we set this flag as 1 to be like, we want to stop this loop. Otherwise, we're just printing out the number that we read in. So let's try this one, and then we'll modify it a little bit. Thank you, Sophia. Okay, what's happening here? This is what happens when you don't do printfs to prompt the user what's going on. They sit there thinking, have I done something wrong? Anyway, it's just an example. Let's type some stuff in. I entered 1, I entered 9. We're counting 0 is okay here. It's only a negative number that's going to stop it. So it's going to keep letting me enter stuff. As soon as I enter -1, it's going to stop. It's all right. Hey guys over there, just be quiet because the people at home have difficulty hearing it if people are too noisy in here. Plus then I start speaking loud so I can hear myself. And then you all have to hear me kind of yelling. I know, I apologise for that actually. So when we entered this negative number, we changed our variable to 1 to say please end the loop. Now, are there any questions about that? All right. So what we're going to do is we're going to take the exact same code we just looked at, but first let's modify it. Instead of just reading in numbers, let's calculate the sum of all the numbers that we did read in. How would we do that? So this is a common thing to do, take a sort of running sum. So I'll have a variable, I might as well call it sum, and I'm going to set it to be 0. Every time I read in a number, I add it onto my sum. So I don't want to read in any negative, I don't want to add the negative number I get at the end. If I get a number that wasn't negative, I say sum equals sum plus whatever number I just read in. Okay? So once I get to the end of the while loop and they've entered a negative number, we haven't added that negative number to this sum, but we print out the sum. Okay. So let's try this. Let's test it with something where we know what our answer should be. That's always a good idea. Don't throw heaps of numbers in there and think, oh, I don't know if that's the right answer. 99, 1, I can do that. 5, let's stop there. Oh, what have I done wrong? I'm running the wrong program and I compiled the wrong program. Let's try this again. Okay, 99, 1, 5, minus 1. The sum was 105. Now, what if I wanted to include negatives? What if I wanted to be able to add up just all the integers? And what if I didn't want to stop when I got a negative? I wanted to stop when somebody typed in something that's not an integer at all. How could I do that? How can I tell using scanf if somebody typed in an integer or not? Does anyone remember? Yes, so our scanf, if we read in an integer, will give us back what number? If we ask it to read in one integer and it does, it'll say, yep, I read in one integer. If we ask it to read in one integer and I type hello, it'll say, I read in 0 integers. Yep.
If I'm not wrong, you have to set scanf as a variable itself, right?
Well, what we do, we have another variable here. It's starting to get tricky. I can call this whatever I like, num red or something like that, meaning the number. So when I do my scanf, I get what we call a return value, but it gives me back a number that represents how many things it successfully read in, and I can store that in a variable. Now, I need to change my condition now, so I'm not stopping if the number I read in was 0. When am I stopping? Yeah, so if the num that I read in, maybe I should say, I'll call this actually, instead of num read, I'm going to call it valid int.
Also, is end loop redundant now, or?
Well, we can still use end loop for now. We could refactor this code a little bit yet. We could change it around, but let's leave it like this for now in the same pattern. So if we didn't get a valid integer, then we want to end the loop. Okay? Is this going to work? So 2, 3, minus 3, keeps going. does it end when I type in something like A? Yeah, it does. Did I get the right sum? Yes, I did. Okay. So this is one way to do it. We could rewrite this code a little bit if we wanted to, and you'll probably see that in the tutorial. You'll do lots of stuff where you're using scanf in a loop, and you end based on this kind of condition. Okay. All right. So, and maybe I can show you that as I'll rejig that program for you at the beginning of the next lecture as revision maybe. Okay, we've already had our quick break. We're not having another one. I'd like one. So, one loop is not enough, right? We want to have loops inside loops now. And this is called nested loops. So, one really good way of thinking of a nested loop is like a clock. So if we've got, and I don't know that people really see clocks like this anymore much, right? Are you all used to seeing clocks like this with hands? No, yeah, that's right. I'm old. So maybe this isn't the easiest way to think about loops. But on this clock, we've got 3 hands that are going around, and the hands that are moving, they're like the counters in a loop. And every time a minute hand moves to 1 minute, how many times does the second hand go around? 60. And then every time we move from 1 hour, how many times has the minute hand gone around? 60. Every time we go for an hour, how many times has the second hand moved around? Yes, 60 times 60? Anyway, lots of times. So we can do this kind of thing with nested loops. Okay, so I could do a loop. Let's try it. Actually, we won't try that for now. We'll do a different example first. But the point is, there'll be a loop that happens the most often. That's the one we put inside, because that's going to happen 60 times for every second, every minute. So the outer loop will go through once, and the inner loop will go through 60 times. The outer loop will go through again, the inner loop will go through 60 times. All right. And star means, if you notice I typed star, a few people have asked, it just means anything.c. Open up any C code in this directory. Oh, am I in the wrong directory? Okay. All right, we will write that clock later. Yeah, let's save that. Okay. So why are nested loops useful? One, you know, for things like clocks. Often we've got things like this where, all right, here we're just printing out numbers, but often we've got like boards, like chess boards or checkered boards or obstacles, things like this where we might use loops to print out a grid of stuff, or a triangle of stuff, or I don't even know what this is, some pattern. And we can do this with nested while loops easily. Well, if we know nested while loops, yeah. If this is your first time ever seeing while loops at all, and your first time then seeing nested while loops, it's not going to be easy. It's not something you're going to walk away with the first time you see it and go, yep, I'm going to go home and write all these perfect nested while loops. It's going to take time practicing it, looking at it in tutorials. All right. But yeah, we can print out something like this. Now, some of you are sitting there thinking, I already know how to print that out. You do it like this. True. True. That is going to work. But like I said, what if it was 1,000 or 100? What if the user typed in, I want a grid of size 10, and you had to do it matched to the size the user typed in rather than just hard-coded 5? So yeah, that's not great. How could I just, to make it easier, how could I forget the original question but just print out something like this with one loop? I just want to print out 1, 2, 3, 4, 5, but with a loop. Yeah? That's right. So we can do a loop and we can have some sort of counter and check that that counter is less than 5. So let's try it. Now, I'm going to call my counter, I'm going to call it col for columns, not colon, col for columns. Because these will sort of be columns later on. I've got column and I'm going to check, I'm going to keep going while column is less than 5. Instead of typing in 5 here, what should I type for style? Yes, size. But it's the same thing for C, but not the same thing for style marks. What should I initialize col to? 0? And what do I print? Let's just try it. I just print %D, and I need to get rid of these pop-ups. And I just print in col. What's wrong with this at the moment? There's a few things. What's the worst thing? Will this terminate? What do I need to do to make sure this? Yeah, I said col equals col plus 1. Yeah, we'll see that later. Let's try this. Okay, so this isn't 100% what we're looking for. First of all, at the end of this printout, it'd be nice to have a new line, right? There we go. Compile it. Yeah. What else do I need to do? Yeah, I want to initialize it to 1. That's correct. And yeah, I do want to change something else as well, but let's just do one thing at a time so we can see. I'm starting at 1 now, which is what I want, but now I'm only going up to 4. 1, 2, 3, 4. I want it to go up and include 5. So I can do it like this. Anything else? Yeah, we wanted some space. So I can just put that in. I'm going to end up with an extra space at the end that I can't really see, but that's fine. Okay. Is everyone happy with this loop? Just a one-dimensional loop. Okay. Now, if we go back to our original problem, we're now able to print out one row. How many times do we actually want to do all of this? That'll print out one row. We want 5 rows, so we want to do all of this code we just wrote 5 times. I could copy and paste it 5 times, or I could put it inside a loop. So I'm going to actually indent all that a little bit further, and I'm going to create another loop. Now, if I want a loop that goes through 5 times, we know how to do that, right? I'd have some kind of counter. Now, I can't give it the same name. I'm going to call this one row. And we're going to start at row 1. And we're going to say while row is less than or equal to size. And what do we do for every row? Well, we do all of this stuff that we just wrote, we want to do that every single time for every row. But we also need to do what? Yeah, increment our row counter. Otherwise, we're never going to stop. So I've got to say down here, row equals row plus 1. So if you just take away this for a moment, this just looks like a very simple, lovely, beautiful while loop. And then I put this back in, right? But before I had that external while loop, this looked like a simple, beautiful while loop as well. But now they're nested. But we've got our while loop, calling our while loop that prints out a whole row. Let's see if it works. Do we think this is going to work? Oh, good. All right, this is nested loops. Okay, it takes a bit of time to get used to writing these yourselves, but hopefully that kind of makes some sense. All right. Now, let's have a look at this thing here. How could we take the code we've already got and change it to get this slightly different pattern? Oops. No, not that slightly different pattern. This pyramid-y, triangle-y thing. So there's different ways we can do this, by the way. There's not always just one way. Yeah?
So we'll make it row less than equal to column instead of size.
Okay. We had a really good idea here. But let's just talk about it a little bit first. So when I'm printing out row 1, how many things do I want column to print? How many columns do I want for row 1? So for row 1, I want 1 column. For row 2, how many columns do I want? 2. For row 3, so I've already got a counter. So instead of my inner loop always printing out 5, right? It was always going up to less than or equal to 5. So I was always getting 5. Here, I want it to go up to whatever the counter of the row is up to. So for row 1, I want it to go up to 1. Row 2, I want it to go up to 2. So I've got a variable that already is tracking that information for me. So if I go back and if I go back to my code, I'm going to take this code. I didn't mean to do that. Here. And instead of having this inner loop go up to size each time, I'm going to just let it go up to row. If we're row 1, we print out 1 thing in this inner loop. If we're row 2, we print out 2. And I'm going to try and compile the right code. Yay! So, and that was your idea. Very good. Oh, chocolates. Sorry, what's your name? Anusha. All right. Sophia's getting her gym workout today. Sorry, Sophia. All right. Does that kind of make sense? All right, cool. Now, when you see more of these problems, it will be more sort of obvious to you what to do. You'll get used to them. I'm going to leave this pattern for you to try out yourselves, but I'll do it as revision at the beginning of Monday's lecture. And I'll do the clock then as well. All right. So we'll do more practice with those nested while loops later. Let's look at something else now. We've got this thing called custom data types. So far, we've been using all the inbuilt data types, this like int, char, double. We can make our own data types as well. which is really powerful. That the first one we're going to do is structs. So if we think about this kind of data, this is how we would have had to store it so far. So can anybody see anything that isn't great about this? Like, what's the, why am I calling this related data? What is this? So yeah, I've got lots of data related to sort of sorry, Brianna. I've made up the data, right? I just made it up. I'm not actually 23. I don't know how old Brianna is. It's just all fake. I have no lab mark. So all of this data here is about Brianna, supposedly, or a variable named Brianna. These variables about me. But they're all related to a particular person. So it would be really nice if we could package them up into one variable with a person that can contain a first initial, a last initial, an age, and a lab mark. Or maybe a student. I mean, I'm not a student, but this is all just an example. Yeah, it'd be nice if we could do that. What about on the other side? What do we have? This looks a bit cryptic, maybe. But for people who do maths, what does this look like? Yeah. So this might be 1 point, this might be another. It'd be nice if we had a way of storing a point. So in C, there's no built-in person with the exact same configuration I decided a person would have in this example. There may be some library that has points, but we can make our point type as well. So this is where we do something called structs. Oh, sorry, that was my beautiful slide boxes. So structs allow us to design these types and design what the fields are that go in them and the types, and also give them a name. So I'll just run you through it. So the first step is we define our struct. So this is a design or like a blueprint. This is not creating any variables or asking for any memory. This is saying to C, when I say struct student, this is what I mean. When I say struct coordinate, this is what I mean. When I say struct student and create a variable of that type, I'll need enough memory for all of these things, etc. So we have to use this keyword struct, and then we just give it some name, hopefully that means something meaningful. Inside, we call these things members or fields. I typically call them fields. I think in C, technically they're members. Anyway. All right, that's the first step. Now, once we've done that, ideally we've done that because we want to use it in our program. So we want to make variables of that type. So these structs won't go inside your main. You'll put them at the top. You know, you'll have your hash includes, your hash defines, then you might have these structs. Down in your program where you're writing your code, you'll use this like a type, right? So, you know, usually you declare a variable, you might say int x, if x was a meaningful name, right? Here we're doing the same thing. The type is struct student. So we have to keep that keyword struct there, but this is the type we designed, struct student, and this is our variable name. And it's at that point where C gives you a chunk of memory and says, okay, here's a chunk of memory for your struct. And it's going to be big enough to store this whole collection of things, right? So we can store a collection all together, and we can have whatever types we want in there. Over here, I've done the same thing. I've declared 2 points. So I'll have a point, I've called them struct coordinates. That's the type. I've made my variable point 1 and point 2. So I'd end up with 2 chunks of memory for these structs. Is everybody okay with this so far? Now, what's the question you're asking now? why are you teaching me this? What's happening? Or how can I put data inside these things? Like how can I access these individual fields, right? Okay. So over here, this is my design or the blueprint or the definition of the struct. In here, again, I've declared my struct, which means I've got the chunk of memory, but I haven't initialized it yet. Here, I'm initializing the data. And notice we use this dot operator. This dot is saying go into that struct and go to this particular part of it. So I'm saying go to my struct student and set the first initial to be B. So in here, there'll be a B stored in that little chunk that's set aside for it. I do this for the last initial. I do this for age and the lab mark. And all that is stored in one little chunk. If I want to get the value out again, I just do the same thing. If I want to modify it, I do the same thing. I say Brianna.age equals Brianna.age plus 1 or whatever I'm doing. Yeah, I've got a question.
Why do you not need to write the student part over here?
Why do I not what?
Write the student in the Brianna.
So this is like the type, right? So when I declare something like int x, x is the name of my variable, int is the type. So I might say later in my code x equals 3 or something like that, and I don't put the int there. So this is part of the type name, struct student. Okay? Any other questions? Yeah? Struct is like a keyword that allows us to define our own type. So the whole type itself is struct student. That's the name of the type. Is that what you just asked? Sorry. Yeah? Sorry if I'm answering not exactly what you've asked. So the struct is a keyword in C that allows us to create our own type. I've created my own type called struct student. You could create whatever types you like with whatever names you like. Yep, another question?
Is struct like a list from Python, like visualize multiple sets of entries in that, or just one set?
It's not like a list. Is it like a list? So we'll see something in C called arrays where you can have a collection of things like a list of, or like lots of different things that are the same. This is different. This is just a collection that we're putting variables together that belong together. I don't want to start comparing it to too many other languages because there's subtle differences, but it's not really like a list. Later on, we'll see how we could have many students, and that would be more like a list of what you're thinking. Okay, so this is just one variable, a composite variable with parts inside it. Okay, it's a form of abstraction. So I can just think of it as a student without having to worry about all the details that are inside it. Okay, and if you think about a real database or a real application, there'd be so much data inside one student kind of thing. Yep.
So types are within the struct.
The types are right. So I can create a variable of type struct student, and inside there, it can store all sorts of different types of data.
The types are within the struct.
Yeah, all of that, that's saying I can store in this struct 2 chars, an int, and a double. Yep.
But then like Brianna, for example, is also has those characteristics.
Yeah, so when I say any variable of type struct student will have all of these, room for all of those in there, all of them, yep, yep. Yep. Oh, sorry, one more up there, yep.
So can I imagine struct like a file type, like you name off the file student and then you put all your information inside the file?
We're not going to cover files in this course.
But could I imagine it as if it was like a file?
Yeah, it's storing something in our program in RAM though, not actually on a file. Yep, yeah. But yeah, it's just storing related data. Yep.
Let's say you want to store another like custom variable inside student. That means you have to define it first outside the student, then you put it inside the student.
Oh, could you repeat that question?
So let's say you want to put another custom data type inside student. To do that, you have to define it first outside the student.
Yes.
Then you put it inside.
You have to define your struct first, and then you can use it in your program.
That means the order in which you define it matters, right? I cannot put student, then define the custom variable under it.
I'm not sure what you mean by a constant variable. Oh, a struct inside another struct. Nested structs.
That means you have to define the struct.
Yeah.
Put it in, not put it in, then define it.
Yeah. Okay, we're jumping ahead a bit, thinking of I don't blame you because I've showed you nested if statements, nested while loops. Why wouldn't you be thinking of nested structs? That's a very good question. Well, but yeah, you can have a nested struct and you'd put that up the top. So for example, my student could have a struct date for their birth date, their date of birth, and we could define a struct date with int day, int month, int year or something. So we can nest them. For now, let's just get used to just the struct, yeah, before we make it too hard. All right, we've got a couple of minutes, 3 minutes. How would I, if I just wanted to set point 1 to have, to be the point 0, 0, and point 2 to be the point 10 minus 5, how would I do it in this code? So how did we set the data? So I've got a point 1, another point 2. Right now they're uninitialized, they've just got garbage in them. How do I set the data inside them to be 0, 0 for the first one, 10 minus 5 for the second one? I say point 1 dot x, and that's going to allow me to store something in this x component inside my struct. Point 1 dot y, and I've got the code. This is what we do. Point 1 dot x sets the first field. Point 1 dot y sets the second field. Point 2 dot x sets the first field in this second variable. Point 2 dot y sets the y field. So this is my x, y, x, y. Okay? So these are structs. We'll be using them a lot. It's just another type we have now that we'll see. That's all we've got time for today. Before I go though, we'll cover enumerations next time. Yeah, I always forget to put the feedback form. So for every lecture, there's a feedback form. Give me feedback. You can give me your email address if you're happy for me to know who you are and you want me to reply. You can stay anonymous. It's up to you. Thanks, everybody.